repairing a Southworth 12-inch steam pump. This one is part 7. Machining the cast gunmetal block into 2 accurately sized pieces, which will become the pair of slide valves. Before diving into a job like this, you need to sit and think about it. I received the kind permission from Jackie at Blackgates Engineering to show the drawings for the slide valves in this video. To make the drawings easier to read, I enlarged them, printed them out, and here they are in the workshop. One thing's for certain on this cast gunmetal block, I do need to square it up before I can work with it. Now it's over to my ancient milling machine, and I'm cleaning up the worst surface first. Rather than chop the block up whilst it's in this state, it's a much better idea to treat the entire thing as one unit. To clean up the block, I'm going to use this face cutter. I've had this for many years and I've never changed the carbide inserts, so they are a little bit on the blunt side. I've machined a lot of things with this face cutter. It must be approaching 30 years old by now. I'm only taking light cuts because gunmetal is quite soft, and I end up with 2 sides that are serviceable. And when I check it with my square, both sides are square. I've mentioned many times over the years in the videos that I am not a machinist or mechanical engineer. I am a sound engineer and a musician. So often I go about these jobs in an unorthodox way. I don't normally write on the drawings, but as these are enlarged copies, it's okay. I've drawn rings around the critical dimensions. This block needs to accurately end up being 25/32 of an inch by 3/4 of an inch by 1/2 inch. I also find it a very good idea to use my deep hole marker to write the relative dimensions on the pieces of metal I'm working with. Making a pair of valves like this, which are similar yet entirely different, can be a bit confusing, but if I write on the piece of metal how long it needs to be, even though this is not one of the dimensions, I've marked it 7/8 because it needs to end up at 3/4, and my trusty old bandsaw, which works very well, doesn't always cut perfectly square. So taking this into consideration is the reason that I mark the part 7/8 of an inch and not 3/4. Even though I started the bandsaw off exactly on the line, it doesn't always follow that it cuts perfectly square. That's why I need some tolerance to work with. In this clip, I'm milling the block that I cut perfectly square, and as you can clearly see, it was far from square. I'm really glad I decided to do this, because had I have marked it at 3/4 of an inch, one side of it would have been less than 3/4 of an inch, which is not what you want with a slide valve. I made a felt tip pen mark on the side, and all I have to do is just cut down to that line. The part of the block that I previously milled flat is resting on a piece of mahogany. I should buy some parallels, but I don't have any of those. The mahogany is a very hard wood and it's cut very square to start with, but I really must make a mental note to buy some parallels. Because I is well old in it, I was taught at school the imperial method of measurement. I'm taking this part slowly just to explain how it works. I need to cut this block at 25/32 from the end, and 25/32 is 1/32 larger than 3/4 of an inch. I scribe the line, and with the bandsaw in the vertical position I cut it manually. And here is a combination of a health and safety warning and a top tip. When holding pieces of metal against a bandsaw blade, do not cut all the way through. As the bandsaw blade cuts through the metal entirely, that's the point where you could cut your fingers. So usually I don't go all the way through if I can help it, I just break the part off like this. And once again, as you can see, the scribed line is miles away from the cut. But this means nothing to the face cutter, and I quickly remove the excess down to the line. So that's one dimension completed. Now I need to reduce the width of the block down to 1/2 inch. And again, this doesn't take long. I'm being very careful and taking light cuts. I do not want to distort the part. Don't forget, gunmetal is a very soft metal, and as such is easily marked. My measuring seems to be okay, because when I use the micrometer, it's exactly 1/2 inch thick. Also, the 25/32 dimension seems to be okay as well. Oh no, the 3/4 of an inch dimension is 3 thou over size. Never mind, I need to clean it up anyway on a piece of 400 grade wet to dry sandpaper. I'm using 3-in-1 oil as a lubricant, and this took quite a while. But the extra 3 thou was soon removed. I just hope that the ports on the port face are as accurate as my valves. We shall see in a future episode. Once again, so don't get confused, because don't forget, 25-30 seconds is only 1/32 more than 3/4, and it's very easy to get it the wrong way round. And after taking all the time to machine these blocks accurately, I would really hate to machine any other part of the valve wrong. Both of the valves are quite similar in size, but the slots in them are very different. One of the valve slots is 1/8 of an inch wide and the other one is 5/32 of an inch wide. I've made a mark on the valve to show where I need to mill the slot, although this is not accurate. I'll be milling the slots and finishing the slide valves in the next episode. The good news is that my 25-30 seconds dimension is a perfect fit in the gap of the shuttle piston, including the tolerance shown on the drawing. Now it's time to show the other valve. I'm not going to show everything about the other valve because the manufacturing process is identical to the first one, in every way except the final dimensions. Here I'm checking that the finished valve block is perfectly square. Now I have to cut the block in two places on the bandsaw. First a cut in this direction, followed by a cut in the other direction. And as previously shown, I did not let the bandsaw blade go all the way through. Back over now to the milling machine to finally size the part. Once I got the block to the size that I needed, allowing a little bit of tolerance for the cleaning up operation, I placed the first gunmetal block that I made on top of the drawing, followed by the second one, and as you can see, the slots are a different size, particularly when I put them together. In this clip of the port face, you can see why the slots need to be different sizes. The small holes operate the shuttle piston. The other valve is controlled by the shuttle piston, and that rides over the larger ports which admit and exhaust steam from the main cylinder. I placed the valves in their approximate position, and as you can see, everything's looking okay. And that's it for this episode. Stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.